So I'm very excited to be here. We were moved from yesterday 3 p.m. until now, thanks to our good friends. We are here today to talk about Swanky Suite. It's the only one tool for WASM smart contract developers. I will not dive into Swanky Suite at the start. I will first go over other topics, but let me first introduce myself. My name is Martin. I'm head of ecosystem development. I've been with Astar for more than 2.5 years. Then we have Sasha. He looks like a badass, but he's pretty sweet, so he's a very nice guy. He is leading the WASM or the Swanky Suite projects. We are doing this currently in-house, but we are working together with other parachains, other ecosystems who are using the pallet contract. Cool. So what I will cover today is one small introduction about Astar for those who are not familiar with us. And I will go over the WASM stack, go over what's WASM, what's WebAssembly, then how does our tech stack look inside of Astar. Then I talk a little bit about Ink, the language that we are currently pushing as well to bootstrap in our ecosystem that interact with the contract palettes to write those smart contracts. And then the Swanky Suite, what to expect, what do we already have. And then Sasha will do like a live demo where he will showcase how Swanky Suite will work. So the first topic I want to talk about is about Astar. So what's Astar? We are a parachain on Polkadot. We have Shiden, who's a parachain on Kusama. We are building a smart contract infrastructure. What do I mean with smart contract infrastructure is that we will be having multi-virtual machines in our environment. We will have EVM, which everybody knows, and then we also have the WASM environment. This is challenging, but will offer the true interoperability with XVM and as well XVM. XVM, it's a talk that Hoon, our CTO, is now giving at the other IGLO, a little bit back. And XVM stands for Cross Virtual Machine, where it's possible to talk with contracts on EVM with WASM, as well as vice versa. So we made it possible to be like interoperable between smart contracts, as well as with XCM interoperable between other parachains. So there are different kinds of layers of interoperability. And like we say as well, we have our website and we offer the smart contracts environment on Polkadot. Cool. So one of the first questions, so here we are in the starter space, so I will go over it at a high level, not go into deep about WebAssembly itself. But one of the major questions that we got is why is WASM or why is WASM smart contracts a better environment for smart contracts? To understand this, you need to know what's WebAssembly. As you can see there below, WebAssembly is designed as a portable compilation target for programming languages. What does this mean? So in WebAssembly itself, it's not designed to code in. So it's not designed to code WebAssembly. It's more as a compilation target. You need to code in some other language and you compile it into WASM. And that makes it accessible for other languages we already know about. We have TypeScript, C++, JavaScript. You can compile that into WASM. So this comes to this as a wide language support, meaning that it supports a lot of languages, and with that language you compile it into a WASM. Then another one is the native performance and the high portability. What do I mean with this? WASM itself, it targets as to run as a virtual machine in your browser. So it will load up in the virtual machine on your phone, in your car, on your laptop. And this makes it like very scalable because what is this as well? This is the high portability because it's very small. And this is great for blockchain because it's small, because it takes very small space in the blockchain on chain, which is great for smart contracts. What else do I want to add as this is memory safe and executed within a sandbox environment. So it's by design very secure because it will be launched in a sandbox environment, so no memory leak is possible. Many blockchains are moving towards WebAssembly or Rust. You can see this as well with Near, Cosmos, Solana. They all are using Rust-based environments. Then again, supported by various industry leaders. So who's building with WASM, who's designing WASM, that are like Google, Mozilla, all those major companies, they are building out WASM as well. And finally, it's a huge potential for the future because it's built for web, it's built for the internet, it's the future of the internet. So how does the tech stack look on Astar? I didn't edit layer 0, Polkadot, but I will start with layer 1. Layer 1 is, for instance, Astar. It can be another blockchain, and that blockchain is built out of Sub0 framework. It's built out of different kinds of palettes. One of those palettes is the smart contract palette, the palette contract. And this is the smart contract engine of your blockchain, in this case. And what does the palette contract do? Well, the palette contract, they expose an API for a smart contract to interact with this palette. And to interact with this palette, with a smart contract, you need to have languages that can use that API. And we have Ink, this is Rust-based, and then we have Ask as well as assembly script. Why it's so important to also have other languages here as well at the beginning is that Rust still has some entry barrier, so you still need to know Rust before you can write smart contracts. So it's also important to have other languages as well to be supported with the contract palette. Currently we have Ink that can support with the contract palette. We have Ask and also Solang, the language that you compile your Solidity into WASM. Another layer I added here are the Polkadot standard proposals, the PSP. Those are created by, you can find them with OpenBrush. Those are the standards for PSP 22. It's like an equivalent to the ERC20, as well as the PSP 34, an equivalent to the NFT ERC 721. So a small overview again. The palette contracts, so it exposes an API to interact with smart contracts. It's agnostic, so you can use any language to code your smart contract with. It's decoupling the language layer and the execution layer, and it allows for any programming language to be used to build smart contracts. But there are two requirements. One is the language should be able to compile into WASM, and the second one, it should be compatible with the palette contract API. So a lot of people are also asking us, okay, we have this kind of language, it's also Rust-based, it's WASM. Why can it be deployed on Polkadot? Can it be deployed on Astar? As long as it's not compatible with the API of the contract palette, no, that's not possible. But you can create it. We know people who are creating other languages based on Rust, for instance, Move. Who knows, is that coming as well to Polkadot? Who knows? As long as it can be compatible with the palette contract, it would be possible to use. Then the execution environment for WebAssembly smart contracts. We have GAS. This will be used for the rate. This was also one of the major topics from Gavin Woods yesterday, the rates. It's so important as well. And as well, a user is charged for the space that it will be using in the on-chain and the blockchain. The execution engine. So on Polkadot, we are not using WASM per se. We are using WASM, and that's the WASM interpreter to execute the smart contracts that are built with WASM. And it works like very close to the execution of the WebAssembly itself. This is also very great as well, the two-step deployment. What do I mean with the two-step deployment? So the moment when you have like a smart contract in WASM, let's say the PSP22. So you have like a PSP22, you will use this contract. It can be used for other projects as well to deploy their tokens, for deploy their assets. Let's say that contract is audited, it's a standard everybody will be using, so you compile, you deploy, you upload it into the palette contract, and then you will have a hash. And this hash can be you can give this to other developers as well. And the moment they call that hash and they execute that smart contract, they get a smart contract address and they will interact with the smart contract. And this hash can be called by different developers. So that one smart contract can be interactive with a lot of smart contracts. This will give a lot. If you look further about what's the most important thing is space on blockchain, but this will reduce the space that will be used on blockchain. Okay. Then Ink, or Rust EDSL to write smart contracts. Hey, Hoon, back up. So this is how Rust looks like. And this is a Flipper contract built with ink. As you can see, it's similar, but what you can see here are those yellow lines. And what are those yellow lines? Those are the macros to make this smart contract like very easy for developers, because the developer needs to think about the business logic instead about all those executions here, all those macros here. I created like an overview of those macros, but I will not go into deep with this because we will not have too much time. But there are four. We have the constructor, the storage, the message, and the events. A little overview about, the recap about ink. So ink gives a structure to use Rust in a smart contract. It targets the pallet contracts, as I told you before. It's easier for veterans and newcomers to build with smart contracts, but they need to understand Rust because ink is like an EDSL of Rust. Ink leverage Rust, and Rust is a language that's very mature and has a huge community. The community is still very Rust-minded, so but it's very mature community. So the community, the developers of Rust are like very great developers as well. And then also existing tools for Rust also work for ink, and we have then the most important one. Ink is actively developed by Parity, so there's a huge team in Parity who's working on ink, on the contract palette as well, and this is very helpful for us as well. They recently released the beta version of the ink 4.0. Very excited about this because this will change a lot, and we are looking forward to the official release of the ink 4.0. Then I go over the tools and networks, and one of the major tools that we have is Swanky, of course. So this is a developer toolbox, but everything the developer needs to get started with developing smart contracts. You can compare Swanky Suite with Truffle Suite on Ethereum. It will be like similar in this case. So what do we have inside the Swanky Suite? We have the Swanky CLI, and we have the Swanky node. The Swanky node is the developer node that we will use to run our blockchain on. We have several various templates available. You will see this as well in the demo, what I mean with those templates. Compile contracts written in different languages. Currently, we support ink and ESC to compile to. More languages are to expected and will come as well later on. We can do like RPC testing and integration tests. We can deploy smart contracts within the Polkadot ecosystem that support pallet contract. So this is currently being built in-house with Astar together with other parachains, but it's not designed to focus only on Astar. It's to focus on every other ecosystem using the pallet contract. That's very important to understand that we are not building it for Astar, we are building it for the entire Polkadot ecosystem. And a last one, generator import dev or secure accounts. So in the first release, today or yesterday, we released the first release, the official first release. Besides having a full node or the templates based on what we support at Astar, we also integrate with the Falafat contract, as well as the node support to support the Falafat contract. The Ask language is added. We have more templates available. We also added a front-end template, also very important for those who start working with ink, that you know how does the front-end work to interact with that smart contract. And we add the contract end-to-end testing support as well. What to come? Much more projects, much more templates, looking to create a more comprehensive documentation, support other WASM chains, also very important. Like I said, we will not focus only on Astar, we focus on much more chains as well, and add a GUI as well, a GUI, to have like a better, how do I say it, friendliness or developer-friendly environment as well. We are, like I said before, working very close with OpenBrush, using the standards that they designed as well. I will not go into deep with this. You can check out OpenBrush for it. And then this is our network currently. Like I said, we have shorten. It already supports WASM and EVM, so you can already deploy WASM smart contracts. You can already deploy EVM smart contracts. For Astar, we only have EVM, not yet WASM. Why we do not have WASM yet enabled? This is because it's currently still on auditing, so the contract palette is currently being audited, as well as I know that the ink language itself also by OpenZeppelin, so we wait until the auditing is complete and everything will be done, and then we will deploy it as well on Astar. But currently already available on Shorten, so you can already test out and play around with this as well. And then I give the stage to Sasha, who will do like the following demo. I'm not so sure if you want to talk about this first.
All right. I mean, let's just show it, not talk about it.
Okay, cool. So he will just play around and show you the Swanky Suite. And after this, we will have a short Q&A. Regarding technical questions, I refer them to Sasha. If you have any general question about Astar or the ecosystem, just come to me or ask me the question.
All right, welcome back again, everyone. Thank you, Martin, for the great presentation. And now let's try to add some weight to Martin's words by some deeds. Okay, so Swanky Suite. I have installed Swanky CLI globally on my machine. Let's just check it out. Okay, so I have the release candidate 4 installed globally. But okay, I'm getting signals to zoom in a little bit. Is it okay? All right. Okay, so let's first like maybe do a little show of hands. How many of you have deployed a WASM smart contract to like anywhere or just played with it or like? Okay, whoa, nice, tough crowd. Okay, so about how many of those have instantiated it, started it, and started like deployed it for the first like test version in under 5 minutes? Nice. So you guys have been using Swanky, right? No. Okay. All right. Let's try to beat that then, right? Okay. So let's first start the project. Okay. You'll notice I'm cheating a little bit. We'll call the init command and we'll call the project Sub0 demo. It will ask us a couple of questions. We'll start with Ink. As Martin explained, it's kind of bigger and better supported right now. And right now we have just a couple of templates available. Most interesting is PSP22 because it's more like featureful. We're gonna keep the default name. This is my name from Git. It doesn't need to know my email. And yeah, it offers to download the Swanky node. Swanky node is very useful in this context because it's optimized for Swanky Suite, obviously, and it allows you to very quickly deploy and test your contract because it has instant seal. You don't have to wait for the block time, and it's just convenient like that. Okay. We're going to download it and yeah, install the dependencies. This might take a bit of time because of the internet speed, but in the meantime, we can maybe show how the project looks like. All right. Oh, no. I gotta cd into it first. Okay, so we have successfully instantiated the project, and now I'm just gonna run the compile command because that's gonna take a while to finish. So while that's running, I'm gonna show you how the project looks like. So it's as easy as just calling Swanky contract and compile. We called it PSP22. All right. So, and this is actually intentional. I have to actually cd into the project folder because it's expecting the Swanky config to be present. And now we're going to run that. Ink is currently compiled using a type chain created by Supercolony or 727 Ventures. So thank you for that. Okay, and once we instantiate the project, it's going to look like this. I already mentioned Swanky config. It's going to have initially couple of items in there, which is like the default addresses, default networks, and the contract we just instantiated in there. Right, it's going to hold the contracts in the contracts folder. Right now, it only has the PSP22 contract, and it's going to add some tests for you as well, depending on the template, but as Martin said, we are adding those as quick as we can. All right, so let's try some other interactions while we're waiting for this to compile. Let's see accounts command. All right, so yeah, every command has its own like help text to help you figure out what's what in there. So right now, Swanky command, Swanky account, we can try to list it. All right, and like yeah, as I showed you here, it only has Alice and Bob configured. But let's add one more. Oh, yeah, I should have read my own thing here. It says create. Okay. So it will ask us, is this a dev account? This is very important, as some of us have learned. Yeah, it is a dev account. And we're going to get a nice warning there, so we should follow it. Let's say this is Charlie. And we're going to call it Charlie as well. Okay, and now if we check out our config, Charlie is in there, mnemonic is visible, but let's do one production, and we're going to ask it to generate the mnemonic for us. No, this is not a dev account. Okay, so now we see the mnemonic, and this is the last time. I swear, it's going to be called prod1. And my super secret password, 4 characters. Okay, so now we have our encrypted account here as well, and if we decide to use it, which we want today because I don't want to, deal with passwords and stuff in front of the crowd, it would ask us for a password whenever you're interacting with contracts. Okay, so this is compiled. Right, so let's see, we want to test it now because we have a test included with the template. Okay, so let's say Swanky. Oh no, actually, test is still using yarn, but yeah, we might or might not change that depending on the actual need. Okay, now it's going to error out. Why? Because we need some destination for that thing, right? Okay, but that's easy solvable. Let's just say Swanky node start. Okay, now it's starting the node, which I did not show. I think it's here in the bin folder. Okay, and now let's try the test again. Silent prayer to the demo gods. All right, works. Woo. Okay, so if you've been following here, it has like deployed a couple of times and queried and run some transactions in there. Okay, so now our contract is tested and ready to be used. Let's deploy it. Which one? We're going to deploy PSP. Yeah, we're going to pass in Alice as a deployer. We're going to give it some gas, and we're going to set this big number as initial balance. And there we go, deployed. Woo! Was it under 5 minutes? I didn't count. Yay! Bravo us. All right. So we have been talking about. Well, actually, I think we're like. I'm doing this rather fast. Let's do something wild. Let's do it. Yeah, let's deploy it on the live testnet as well. Because why not? We can. This is gonna take a little bit more time. It shouldn't. Yeah, just to show it's going there. I'm gonna kill this node here. All right. And we are deploying. And tension, right? All right. Now I could just go there and watch the. Yeah. Oh, did I ever catch that? It's probably here somewhere. Uh, anyway, yeah, I'm not gonna go and like look for it. You're just gonna have to take my word for it. Like, let's check the config. So now we have some more data here in contracts part. We have PSP22 and deployments, like we have two of them. One is to the local network and one is to Shibuya network. We get the address in there and the deployer alias, and if you look at the alias, it's here if you need to find it. All right, and Martin also mentioned the Ask language. It is something that we have like big hopes for, and that's why we have included it in here. Like for like one big reason that it's based off of assembly script, which is in itself based of TypeScript, which is much more accessible to majority of developers out there. So let's try to add a new contract. Swanky contract. We'll say new, and we're gonna call it as flip because you're guessing we're gonna use the flipper template. All right, ask. Let's do flipper. Still my name. Still no email. All right. Now it's adding ask to your project because it wasn't needed before. If you look at the contract folder now, we have the ask flip as well. And here under contracts, we have ask flip with the language of ask and still no deployments or builds. Okay, it's there. Let's build it. Let's do compile and ask flip. Okay, this should be rather fast. And done. Yeah, we have compiled it. It's built in here, and let's start the local node again. I don't want to deploy yet another flipper to the testnet. Okay, let's do Swanky contract deploy. Flip, same account, same amount of gas. I'm gonna pass it false as the initial state, and yeah, it's there. It's deployed. All right, that's about it. Was it fast enough? Okay, so I think I've showed most of it. Let's have some questions if you have some. Like, I'm gonna hit you with a ball if you raise your hand, but that's a good thing. Yeah, woo!
Kind of a simple question. The Swanky node, what exactly is a Swanky node? Is it just like a stripped down substrate node with a
it's an Astar node with some added features. Like it has pallet contracts, but with some additional stuff like instant block seal. So you don't have to wait for the block time. Like whenever you submit a transaction, it will create a block. So that's like super useful for testing, for example. And
like if you wanted to be able to support a non-Astar network in a similar sort of Swanky node way, is that possible to do, or
you can like wait. For example, here you can just add your own. Like if your node has a different address, just add it here. Or like if you want to just like put another node in there, just like call it Swanky node and like put it in the bin folder. That's like I forgot to mention at the end, like we are still like making it as we go, so like all of these suggestions are like welcome. Go to GitHub, make an issue, make a suggestion, make a, like we are happy to like have like any contributions. So, and like more about Swanky node, there's like here. So yeah, there's a better explanation than I can conjure up right now. Yeah. All right. Any more questions? You should just like toss it randomly. Okay. Okay, there.
Hi. So you mentioned also the front end. Do you have the example front end?
Right now, no, not in the suite, but we have the example front ends in the repo. So like you can, there's a bit of like handiwork. So you gotta like download the repo and hook it up yourself. But it's definitely like next feature that's coming.
So you also have like the sample integration with polkadot.js extension for signing transactions?
Yeah, that's in the UI example repo that we have in our, like, it's in the Swanky repo, right, Mario? Okay, yeah, you can find it on our GitHub.
Hi, I wanted to ask how flexible the Swanky node is. Can I supply it with my own runtime? Like if I have some chain extension on some additional palettes that I would like to test, is it possible to use the Swanky node with this nice feature of instant seal, but use a completely different runtime?
Well, you're welcome to like download the repo, like do whatever you want and compile it. You know, you can put it in there. Yeah, and like if you as Martin mentioned, like we support plugins. So for example, if you need something like special for your network, you can like easily create a plugin and then just use like Swanky your network node start, you know, and it will call that.
Okay, thank you.
Yeah. Right? You can try to toss it back to me, or
do you plan maybe to integrate it somehow with contracts UI? Because contracts UI is very nice UI for deploying contracts, but unfortunately it works only with contracts deployed with it. So
we did not think about it, but as I said, like go and make a suggestion, we'll consider it. Like anything like that would like make the developer part like easier. We're happy to consider. Yeah.
Okay. We are already connected to the contract UI that's in the repo of Parity. Our networks are already in there, so you can already use it. But you don't need the Swanky node for this. But you can need the Swanky node to generate your smart contract, create it, and upload it in the contract UI. That's what you can do.
For example, if you use Swanky deploy, then that contract won't be visible in your contract UI even if you connect to Astar or shouldn't.
Yeah, you can deploy your smart contract into the network, have that hash, and then open it in the contract UI. Not possible? Okay, then
it is possible with polkadot.js, but not with contracts UI.
Okay, I didn't know. Sorry.
Yeah, that's something else. All right. Any more questions? All right, just hit me then. All right. Anybody else wants to get hit? If no, going once, going twice. All right. In that case, thank you very much. And yeah.